A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. I welcome you all in today's online applied physics session. Hope you all are fine and having good health. We start today's session with some words of Holy Quran. In previous session, we was discussed about the application of applied physics in the field of electronics, and the subdivided topic of our session in the field of application of applied physics was resistor. So the resistor are the basic component out of three, which was capacitor, inductor, and one of resistor. And resistor is extract from the concept of opposition effect of current, which is called the resistance. We called as a component a resistor. So in previous session, we all discussed about the concept of resistor. Color coding aspects are the bands on which based consist by the resistor, and it's a two-terminal device in which the incoming and outgoing current are enter and out from these two terminals. And these are the mentioned color coding in we was discussed in our previous session. Resistor types and precision. So resistor are the device which are consist by the coil of resistance that wire is wound by a rod, which is the insulated stick on the tube on which the consistent of wire is wound in this way. So it leads to the pigtails like this one, and internal aspect of this resistance we can also be made by the component, which you can see that it's a 68 ohm resistor, and it is made by a metal end cap. The internal aspect, the ceramic tube, nickel resistance of wire by which it is wound, porcelain coating, the upper terminal, upper coated layer, which is the porcelain of material, connecting end of two wire, this one and this one we can see. So another aspect type of resistor are the film type. So you can see this is the film type resistor, the connecting two terminals, resistance element, color code on which we can understand and we can encode the band of values. In previous slide, we already discussed this. Molded insulated jacket by which is capped and further looks like in this package. Resistors like a variable resistor, we can also set it's a potentiometer used for the volume control and other applications in electronics and electrical as well. So the symbolic representation of resistor, of variable resistor or potentiometer can be see this, and the potentiometer and variable resistance we can see it's a three-terminal device, incoming, outgoing, and this one is the its variable. So these are the two symbolic representation of variable resistance in schematic diagram we see in different diagrams. And the internal structure of that variable resistor or potentiometer, you can see that the N terminal, this one, and another one is the and another terminal. The moving contact of terminal, which we called a varic and variable, is the middle one. Adjustment of shaft, we can vary by this middle terminal, middle shaft of rod, by which we can vary the value of the resistance. Moving contact, and this one is the resistance of coil of wire by which is made. Now another one is calculating resistance. So there are two kinds of circuits on which the resistance can be connected. Number one is the series combination. The one resistance R1, R2, R3, and 4 starting to end from a battery terminal of positive towards negative in this way. So this schematic symbol of resistance diagram of scheme, we can say it's a resistance of series combination. And in series, why series? Because it is starting towards ending, connecting by the another resistance having the upcoming terminals. So this scheme of symmetry, we called it a series combination of resistance. The equivalent resistance of this series or the total resistance we can find out by the value of the formula R equivalent equal to R1 plus R2 plus R3 and plus R4, and the voltage it adds up as well in this combination. And another way we can say that individual voltages are divided in individual these resistances. So voltage are divided in series combination of resistance of this scheme. Another aspect, which is the parallel combination of resistance, in which the R1, R2, and R3 are connected in parallel schemes from positive towards negative of the battery respectively. So in series combination, the resistance would be increased, and in parallel combination of resistance, it would be decreased. So this is the fact on which these two schemes are based. So the current is divided in this scheme, but voltage is same. Vice versa, the voltage is divided, but the current is same in series combination. So equivalent resistance formula would be 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And we also already discussed that the current is divided in this parallel combination of a scheme. So calculating resistance, these are the two schemes of series and parallel, in which we understand the concepts of series and parallel connection of resistance, as well their equivalent calculation of resistance as well. So moving further, these are the concept of practical uses to reduce the current flowing in the circuit. Use resistance in parallel. If we need to oppose the current, then we need to increase the number of resistance in parallel combination. Then the current would be divided in these paths in this ways. So current would be divided. So this one is the reduction current combination of requirement by which we can reduce the current in particular circuit if we need to that. Then to reduce the voltage of any current of the circuit, use a resistance series combination. You can see that these three resistances are in series combination, then the voltage would be divided in these three combinations, but the current would be same. So for dividing of voltage or reduce the voltage, we need to combine them, connect them in series combination. And if we need to divide the current, we need to connect resistances in parallel, then the current would be divided. Now further moving toward the second category of component, which is we called a capacitor. Capacitor is a device or electric device which is used to store electric charge. So this basic definition also is in first point. The basic unit of capacitor is in farad. Series combination is of capacitor 1 upon C equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, which is the opposition effect in the series of resistance. In parallel combination, the capacitor would be increased, that C equivalent equal to C1 plus C2 plus C3. Then we can say that in parallel combination, the capacitances would be increased and series it would be decreased. So opposite to resistance, both the concepts of parallel and series are opposite effect as compared to resistance. Capacitance is determined by the three factors: plate of surface area, we can find the capacitance, and the plate of spacing, and insulating material, which is the dielectric medium in between the plates. So variables determining the capacitance, which are the capacitance, varies directly with the plate surface area. You can see that the area of capacitance based on the capacity in which the capacitance would be increased or decreased. Distance between the plates, how much increase or decrease the capacity would be based on this concept. Capacitance varies inversely with the distance between the plates. If we increase the distance between these plates, then the capacitance would be reduced. And if we, the vice versa concept, if we increase the distance between the plates, capacitance would be decrease. And if we decrease the distance between the separation of distance between the plates, then the capacitance would be increased. So capacitance would also be vary with the types of insulating material on which we use. So low capacitance if the air dielectric would be in between the plates, and if the mica, if we place in between these two plates of the capacitors, then the high capacitance would be found by this concept. So dielectric material also based on the capacitance value. So parallel capacitors increase plate area, increase charge of the C. So if we connect these two capacitors in parallel, then the capacity would be increased. How much? 2 plus 2 microfarad become 4 microfarad. And if we connect these two capacitors of 2 microfarad in series combination, then the equivalent of these capacitors would be reduced as the 1 microfarad value. So the fact already discussed in a previous slide that in parallel combination, the capacitance would be increased, and in series combination, the capacitance would be reduced. So the uh, this slide also tells us this same concept. Capacitors store energy in electric field. So these are the two plates of capacitors. They are controlled by a switch, which can be open and can be closed. So connected by the battery. So no charge is placed in between these two plates. So we need to switch, close the switch, then these plates store electric charge in it, and we can say the capacitor is fully charged in some kind of time. So if we close the switch by this way, then the charge flow from negative terminal of battery store electric charge. It's also plays respective charge opposite to the positive plate of battery, that negative and positive. In sense of that, after the closing of switch, the negative charge is also be completing the circuit in this way. So negative charge electron surplus and the positive charge electron deficiency, the electron hole pair, the electron proton pair, the positive negative charge of pair, the shared pair of electron, these are the concepts are imposed on it. And the summarized way we can say that the plates of these capacitors store electric charge on it. So we already discussed the concept of variable resistance concept. Same the concept is also be applicable here. The variable capacitors that vary the capacitance by its variation. So shaft connect over here, stator plates, rotor plates, and a rotation. So this rotation of the half set and full set can based on to control the variation of capacitance, and by separation and movement of these half of plates, the variation of capacitance would be feel. So this is a concept by which we can understand the variation or variable capacitors, how it fulfill. So in figure A, you can see that the cross section of these plates would be formed by this way. Shows shaft and stator rotor concept would be fulfilled by this rotation of half plates and full plates, by which the capacitance would store electric charge and reduce its charge. So compression terminal based in variable resistance, variable capacitance would can also be understood by this concept, that the moving plates over here set of screw by which we can change the position of that particular half of set plates. Then the fixed plate provide its charge to the opposite side, and the screw of plates can adjust its position, and the capacitance can also be varied by its moving screw of sets. So insulation also be lie in between these plates. by which the capacitance would be vary. So practical use of capacitor that used for making the timer circuits. So this capacitor consists by this. When used with resistance, use in clamper circuits, used for providing the instantaneous large power as in flash of cameras, and used in DC filter circuits as well. So these are the practical use of application of capacitors of fixed value and variable value of capacitors by which the further devices and applications drive. So coming towards the third component, which is the inductor. Inductors store energy in magnetic field like a little electromagnet. Basic unit of inductance is the Henry, based on the scientist name. In parallel combination, the inductances are B looks like 1 upon L equal to 1 upon L equivalent equal to 1 upon L1 plus 1 upon L2 plus 1 upon L3. So this is the combination of parallel, looks like similar to the resistance combination and opposite to the capacitor. And in series, it would be increase of equivalent inductance value like resistor, which L equivalent equal to L1 plus L2 plus L3. So it's like a similar as resistor and opposite as the capacitor. Inductance is determined by the four factors: the number of turns on which the number of coil of set of turns which can be made, permeability of the core by which it made, cross section area of the core, and spacing of the turns by which it make even also. So please see this slide and we need to discuss it. So these are the variable inductance value. The four concepts are number of turns, permeability of core, cross-section area of the core, and spacing of the turns. We can find here that the number of inductance, the inductance would be low if the number of turns are uh, less number of turns. If the high number of turns would be high inductance value. Permeability of core, if the core have hard steel, then the low inductance would be found. And with the soft core value, then the permeability, due permeability of the core, we can found the high value of inductance with the soft iron core. So cross-section area, if less, then the low inductance would be found, and the cross-section area is high, then the high inductance would be found. Spacing between the turns will provide us the low value of inductance, and the spacing less in number of turns around about the core wound by the conductor, then the high value of inductance in the less number of spacing we found. Inductance would the part of inductance store energy in the form of magnetic field. If the current is flow in the state of rod, state of way, then the magnetic field would be flow in this way. And if we make a number of turns of coil in this way, then the magnetic field would be looks like this one. And if the core is inserted in between these number of turns, then the whole magnetic field of concert would be penetrated in that core, and energy would be stored in this way, like of inductance. So these are the types of inductance: air core, adjustable, iron core, and tap. So this one is the diode, and it's a device which is used to convert AC current into DC current. And the symbolic representation and visual impact of that diode we can see here. So types of diodes are LED and the photodiodes, by which we can uh, conduct and glow the electricity and fulfill its latching. So practical use of diodes are using making of gates of transistors, using making rectifiers, use of switches, LED as indicators, photodiodes as lie detectors. So coming towards the fifth component of transistor in electronics, which is the concept of transistor, which is made by the semiconductor device. It is used in two applications, mostly, which are the switching applications, and second category of application is amplification. So diode is a three-terminal device: emitter, base, and collector. So there are two types of BJT of transistors: NPN and PNP. So NPN is the straight switching device, and PNP is the inverting switching device. So PNP is if we provide a positive supply to the base terminal, logic would be high, then the conduction would be formed between the emitter, collector to emitter. And if the base is low of logic, then the collector to emitter cannot be fulfill the switch on logic, it would be switch off. So the inverting application of PNP is if we provide the inverting negative value in PNP of N junction, then it would be switch off. And if we provide the high logic towards the N, then it would be switch on. So practical use of transistor are they are used as the switching application, which is the on and off. And second category of application of transistor is amplification for realizing the in logic gate as well, the third application of transistor. So this is all about today's session. So hope you understand the concepts. If you have any kind of question and query regarding today's session, feel free to ask. I will answer the kind of question and resolve your queries if you have in your mind. Otherwise, we end today's session.